Hello everyone, this is Mr. Ahmed Waidi من Untitled Chapter Language School, and today inshallah we'll start a new lesson in Unit 4, and in this unit we'll explain the line segment and straight line, and the first lesson about division of a line segment. And this is part number 1. So you have studied before how to find the coordinate of the midpoint of a line segment. Now, can you find the coordinates of the division point of a line segment internally or externally, given that the ratio of the division? So we'll study now how to find any point on a line segment with ratio, internally or externally. So, first, finding the coordinates of the point of division of a line segment by a certain ratio. And we have two types. The first one, the internal division. So we have here line segment. Its start is A and its end is the point B, and we have point C on the line segment AB. So we want to find the rule we use to find the coordinate of the point C. So we'll start with the origin point to the point A, and this is R1 and represented by ordered pair x1 and y1, and we have the coordinate of B will be x2, y2, and represented by the vector R2 from origin point OB. And we have to the point of division, which is C, and its vector is R and represented by xy. So we want to find the rule to find the point C. So we have the ratio between the start point to the point of division, which is called M2, and from point of division to the end point, which is called M1. So if C belongs to AB directed line segment, then the point C divides AB internally by the ratio M2 to M1, where M2 over M1 is bigger than 0. So we have the ratio between AC to CB is equal to M2 over M1. So directed line segment AC and CB have the same direction. So we can make cross multiplication M1 time AC directed line segment equal M2 time CB directed line segment from the ratio AC over CB equals M2 over M1. So we can make cross multiplication. So M1 time directed line segment AC equal M2 time directed line CB. So as we studied before, any two straight lines in same direction, we can find the two straight line with the constant K. So now we have M1 time directed line segment AC equals M2 time directed line segment CB. So we can find the directed line segment AC by the origin point. So by using subtracting vectors, so we can find also CB by using subtracting vectors. So we can write AC equals OC directed line segment minus OA. And we have CB equals OB minus OC. So M1 multiply OC minus OA, and M2 multiply bracket OB minus OC. So we have OC represented by the vector R, and OA represented by vector R1, and OB represented by vector R2. Then we have M1 multiply R1 minus vector R minus vector R1 equals M2 multiply by vector R2 minus R minus vector R. So we can expand this brackets with M1 time R vector minus M1 time R1 vector, M2 times R2, and M2 time R. So we can take M1R with M2R and M1R1 with M2R2. So we have M1R plus M2R equal M1R1 plus M2R2. So we can take R common factor. So we have R multiplied by M1 plus M2 equals M1R1 plus M2R2. Then we can find the rule we use to find the point of division C, which is represented by the vector R, equals M1 times vector R1 plus M2 times vector R2, and R1 represented by the coordinate of the point A, which is X and X1 and Y1, and R2 represented by the coordinates of B, which is X2 and Y2, over the sum of the ratio M1 plus M2, which is called vector form, So we have also the Cartesian form. We can represent R by X and Y, and M1 multiply R1, which is X1, Y1, and M2 multiply by R2, which is X2 and Y2, over M1 plus M2. So we can expand M1 times X1, M1 times Y1, and M2 times X2 and M2 times Y2. So we have M1 X1 plus M2 X2 and M1 Y1 plus M2 Y2 over M1 plus M2. From that we get X and Y equals, in Cartesian form, M1 X1 plus M2 X2 over M1 plus M2, and coordinate of Y will be M1 Y1 plus M2 Y2 over M1 plus M2. So X equal to the first projection here, which is M1 X1 plus M2 X2 over M1 plus M2, and the Y coordinate of the point C will be M1 Y1 plus M2 Y2 over M1 plus M2. So we have also the external division. C belongs to AB ray, so C not belong to the line segment AB. And if I say C belong to BA ray, so C not belong to AB line segment. So if we have here A and B, and we have the point of division of the line segment is externally, and we have also the origin point. So from O to A will be R1, from O to B will be R2, and from O to C will be the vector R, and A represented by X1 also Y1, and B also represented by X2 Y2, and C represented by X and Y. And we have the ratio M2 from start point to the point of division, and from point of division to the end point, which is B, so will be M1. And also we have AB and C in direction of BA, the second case. So from point of division, from start to the point of division, which is B to C, so we have origin point OA, which is R1, and A represented by X1, Y1, and we have B represented by R2 and its ordered pair X2 and Y2, and we have C represented by R and its ordered pair X and Y.